the problem that I saw you were working on, this light intensity problem, and this is the data that you used. And you didn't do it incorrectly, you just did it in a much harder way than we need to do it. And so before you make a video on how to do this, I want to show you kind of what you know mathematically, so you could kind of replicate this and really understand what you're doing. The mathematics you used to do the regression by hand is something that not even my AP stats kids really have to know how to do by hand. And I think if I take time to show you how to use Desmos in a problem like this, you'll be able to use it in the future. And this will be, this idea of using technology to do regression is something that you can do without necessarily being able to fully understand all the mathematics behind it. You really were working on the how is this done, and I'm going to show you how I think you can use what you know now to do it. All right, I said that twice. So let's go. First part it says is let's do a scatter plot, and I'm in Desmos. And Desmos, you can do this on your calculator, but Desmos makes it really easy to see. When we want to put a table in, we hit this little plus sign. All right, and we're going to click on table. So, and now we can just take the data and we can enter it 1.0, 6.09. I need to see it a little bit better. 1.5, 2.51, 2.0, 1.56, 2.5, 1.08, 3.0, and 0.74. Okay, so that's our, and now we can see, if I make this a little bit big, we can see this scatter plot. And it looks like, remember, we're studying rational functions. And if I just look at it, maybe this looks like this side of the curve, and there's a rational function that we don't have data plots for, but this would either look, we haven't studied exponential, so this could look like exponential decay, right? Or it could look like half of a rational function. And since that's what the unit's about, then let's just assume that this is half of a rational function. And if we go to the next part of the question, it says find an equation, right? And here's where the help is. This is rational, right? It's we have the variable in the denominator. And you did a really long, complicated method of this. If I just look at this data table, and I'm going to assume, because I have three variables. I have y equals sum k times x squared. So that's three variables. So three unknowns means I need to know at least two. So the simplest way to do this by hand would be, I'm going to assume that this passes perfectly through this dot, and I'm going to say perfectly, I can pick whichever other one I want. I'm just saying that the line is going to pass perfectly through. I'm not trying to find the perfect line, which is what least squares does, which you were working on. But I'm just going to say it's going to go through this point up here, right? So this is the 1,609, and it's going to go through the third point, which is 2.5108. So we need a place to write some stuff here. And let's get a new slide. So we were told that the function, and this is a big advantage because it told us the function is y equals some constant divided by x squared. That was given to us. We didn't have to guess. Even though when we were looking at it, we said maybe it was rational. All right, and we have these 2 points. We know that x is 1 and 6.09. And we know that we said the other point, we're going to just assume it goes through. It's not perfect, but you can even compare it to the method you did, 1.08. So this is an x, and this is a y, and this is an x, and this is a y. And what I can do is I can say, okay, well, we have 6.09 equals, actually, I only need 1 point to do this. I don't even need 2 points because I have 3 unknowns, and I have 2 in the first. So some value k divided by 1 squared. So k equals 6.09. And if we look at, where's your math? I had it up here just a second ago. Let me go back to your file. Let's compare here. Right, all of this work, we got 6 we got K is 6.13. So we're really not that far off. And if we did it with different points, right? Where'd my, if I took the other point, let's say I tried 2.5 and 2.5, and the y at that was 1.08, then I could say 1.08 equals K divided by 2.5 squared, and you could calculate K. Right, and so we could just say we're making our best guess that which of these points the function actually passes through, and it's really close. So K shouldn't be very different. If the dots were all over the place around here, then we'd get really different K's. All right, but now we want to, it says superimpose the regression curve on the plot, and this is where technology really helps you, and you really need it. So how do I take the data from this table and get it into superimpose? Well, I need to say y1 because that's I want y1, and then there's this little squiggly line, and that's what the computer is registering as to regress. Now regress means to fit it, just like you did all the mathematics behind the regression. It's asking you to say, well, what works here? So I want to know, how does it fit into K divided by x1 is just taking this data point and squaring that value. Oh, look how much better that was, right? I was thinking the other branch was here, but the other branch is here, and it fits really nice. And the closer r squared is to 1, the better the data fits. All right, and we find here's the best value of K to make that happen. Right, so it calculates for you. It does all the calculations that you were trying to work on, and it finds for you what the value of K needs to be to have the best model. All right, now last part. It says use the regression model to predict the light intensity at distances of 2.4 and 4.4, right? And so the distance was the x value. So this is pretty cool. So now in your model, I can say, well, y equals, and I have a K, I have 6.04832 if I use it exactly, divided by 2.2 squared, right? And it's going to tell me, oh, it predicts a distance of 1.25, right? And if I wanted to make that be 4.4, I'll just make my life be faster. 4.4 predicts it to be at 0.312. All right, so you can see there's a couple really cool things. How do you enter a data table? How do you use the squiggly line? Now, why this question is easier than most is it tells you what it wants you to regress it to. It tells you the function that you're trying to fit it to. What makes these more hard in the future is that you have to figure out, by looking at the scatter point, where do you think they fit best. All right, so I hope this helps you so that when you do a teaching video, and I would really pick whether you're going to focus on kind of what is, because when you do your video, you need to teach about the concept of what is light intensity and how does it work, or teach about resistors. So make sure you pick which of the two that you want to do.